Good evening, everyone. Now, the data communication unit one, I'm going to tell. My name is Dr. Gosia Banu. I'm working for MGZ IT department. So, the topic is nothing but data communication reduction. So, let's go to this. Communication model and modulation techniques are the three types are there: the AM, FM, and PM. Amplitude modulation, frequency modulation, and phase modulation. So communication model is a communication model outlines the process of transmitting information from the sender to the receiver. It involves encoding, transmitting, receiving, and decoding messages. The model typically consists of the following components: sender and the transmitter, encoding, transmission, receiving, decoding, decoding, noise, feedback, and the channel. So coming to sender transmitter, the source of information or message can be communicated. Encoding the process of converting messages to a suitable format of transmission, often involving converting the message into digital or analog to digital, mostly digital or analog signal. And transmission media or pathway used to transmit the encoded signal, and receiver is capturing the transmitted signal. Decoding is the process of the receiving and original message format. Where noise is unwanted data or unwanted interference and distortion that affects the quality of transmission and transmitted signal or data. Feedback is nothing but information that the receiver sends back to the sender to indicate the successful reception or acknowledgement of the request clarification. Medium is the physical pathway through which encoded messages travel, that is through the air or for wireless communication cables or for cables, coaxial cables, twisted pairs, and optic fibers for the wide communications. And the channel is the medium or the pathway used for transmitting the encoding signal. So this is the first one is nothing but this is a signal. This is a carrier wave. When this both has been implemented in amplitude modulation, it changes according to this. According to this, and coming to the frequency modulation, here you see that during the upper crest, this is called crest. This is called trough. So there is more congested. The signal has been congested, and during the trough, there is no signal is little there. And this is the amplitude modulation and the frequency modulation. You see here the the signal the signal is being very much very near, and coming to the crest it is being very far. Again it is being congested here and more far. And coming to the phase, because there is high phase and your crest is there and your trough is there. During the crest, it is nothing but it comes to the positive point, again coming here. During the negative phase, again it comes to the negative point and goes here, again the positive point, and then so on. The overview of AM, FM, and is like this: amplitude, frequency, and the phase. So, amplitude of the carrier wave varies as per amplitude or voltage or modulating signal input. Frequency of the carrier wave varies as per the voltage of modulating signal input, and the phase varies per voltage of modulating signal input. Carrier parameters: frequency of the carrier wave is kept constant. Here amplitude is kept constant. Amplitude of the carrier wave is kept constant. Like types is AM can be included BSB, SC, SSB, VSB, refer to DSB, SC. Here, digital during the frequency modulation, digital FM types include FSK, shift key, and global frequency shift key, offset frequency shift key. And coming to the phase modulation, digital phase modulation types are by phase shift key and quadratic phase shift key, And the combination is the corrected amplitude modulation, combination of amplitude and phase modulation. So amplitude modulation, amplitude of the will change with the modulating voltage. Amplitude of frequency wave is constant. Amplitude of the phase is also be constant. Transmitting power transmitting power depends upon the modulating index. Transmitting power is independent of the modulating index. Transmitting power uh, positioning depends upon the modulation index. Carrier power and and one escape power got wasted. Your amplitude, all the terminated power is useful. Um, Only 50% of the terminated power is useful. AM receives not immune to noise. FM receiver is immune to noise, more immune to noise compared to amplitude and phase and frequency. Decreases noise by increasing and you're not possible in phase. Here it is possible, this is not possible. Noise fluctuation is not possible, here noise fluctuation is possible, it is not possible. Modulation technique, here is amplitude, frequency and phase modulation process of adding the carrier signal properties in accordance with the information signal to efficient transmission. The three primary techniques are amplitude, frequency, and phase. The amplitude of the carrier is varies in proportion to the amplitude of the modulating signal. The carrier frequency remains constant, while the amplitude changes according to the variation of the modulating signal. Is commonly used in broadcasting radio. Frequency modulation is a carrier signal is varied of the proportion to the amplitude of the modulating signal. The frequency of one of the carrier is being proportional to the amplitude. Here is uh, the amplitude is of the carrier is being proportional to the modulating. Here, frequency of the carrier is being proportional to the amplitude. Here, the phase is being of the carrier is being respond to the changes of modulating signal. That is the phase modulation. And as the modulated signal varies, the carrier signal resulting in variation of frequencies in transmitting. Frequency modulation is kept resistant to amplitude based interference, making the suitable for high quality audio. Next, the carrier frequency remains constant, but the type, the value changes is based on the modulating signal, PM, commonly used for digital communication systems, and certain types of radar, various types of radar. Each module technique has its own advantage disadvantage, making it suitable for different application based on the factors of signal quality, bandwidth, efficiency,